Today we are proud of the vibrant BAPS community here in Australia, which through beautiful temples across our country enriches Australian society. I look forward to the completion of the large new BAPS temple in Sydney.
Welcome to the construction update of BAPS Swaminarayan Hindu Mandir in Kemps Creek, Sydney. A place where contemporary architecture meets modern technology, creating breathtaking structures. A place that will foster peace and harmony within the community. The cultural precinct is now gradually taking shape. In its current state, 2 building structures have been erected, with their roof work in the final stages. One of the major milestones in the construction is the retaining wall. 4 mammoth retaining walls have been installed, adding to the beauty of this precinct. The height of each retaining wall varies from 6 to 9 meters and a length that goes as far as 150 meters. This result has been a culmination of extensive efforts undertaken by the designers, architects, engineers and individuals who have been integral in the construction of the retaining wall. Let us dig deeper and understand how this milestone of retaining walls were achieved.
Retaining wall is such an important part of the project because it across all the falls and all the levels, the retaining wall then allows for car parks, it allows for the Mandir platform. It essentially defines the site. So the retaining walls play a really integral part.
The greatest challenge is the change in level. It's as simple as that. It took months to solve the change of level. So whilst there was a broad idea of how the entire site would work, there was the reality of the elevation change. There was also the reality of a large overland flow path that had to go through the site.
The site's a very tiered site. And that means that in order to create the various tiers that we need to generate for the use of the site and for car parking and for landscaping reasons, we need to create some pretty high retaining walls. Those retaining walls, at the height is up to 9 meters of retained height. It's quite a challenge to design, first of all to design, but secondly to construct retaining walls of that height. But these retaining walls, as I say, up to 9 meters high. They're certainly, in my experience in 35 years in engineering, they're the tallest retaining walls that I've ever been involved in designing.
To create a powerful wall, they came up with an option of a double wall system, a unique solution to a unique design.
Well, the double wall essentially is 2 concrete biscuits, 70 mil thick. It starts from 70 mil, and then the 2 biscuits are connected with lattice girders, and then it works as like once it's installed on site, and the cavity is poured with concrete, it works as a monolithic structure.
And because it has a cavity in the middle, transport, there's less weight, especially for your job, where you have 400 thick double walls, the largest we've ever made. If you poured a solid wall from bottom to top, concrete all the way, you won't be able to transport as many, and you'll need a larger crane on site. But this product here, because there's a cavity in the middle, and you feel the internals on site, you could transport more and use a lighter crane.
While these double walls are being constructed, the surveyors analyze the design specifications provided by structural engineers and register their markings on the site. This then becomes the reference point for excavators to dig. With such gigantic and heavy retaining walls, it is important to have a right footing to prevent any deflection.
So the footing to the retaining wall does 2 jobs. First and foremost, it supports the vertical load of the retaining wall, and it spreads the load through itself so that the load onto the ground underneath is not excessive. But secondly, it has to be stiff enough so that when the force trying to overturn the wall is applied, the base is stiff enough not to bend itself. The force from The force from the earth transfers into the retaining wall, and that force then is transferred from the retaining wall into the footing. That puts enormous bending on the footing. It puts enormous forces onto the footing. So we then have to assess the magnitude of that force and then design a footing stiff enough to withstand that force. And that's why we've got the reinforcing rods in the footing there, and that's why we've got such a depth of footing to be able to resist those forces, because for such a high retaining wall, the magnitude of those forces is really quite significant.
So much steel was used to make sure the footing is strong enough to carry the load of retaining walls.
Steel that has been used on this project runs, if it was in a straight line, it would be running for kilometers on end. Like, there's no amount of description I can give you on how much steel has actually gone into these retaining walls. When you hear retaining walls, this is not what you have in mind at all. Like we said, this is something we have never seen in our line of work ever before.
At every stage, the inspection takes place, and when everything is as per the expectations, that's when the concrete pouring takes place in between the double wall, which brings solid strength to the retaining wall. These remarkable walls will not only support the Swaminarayan Haveli Precinct, but will stand as a foundation that will foster future generations.